I'm trying to release more frequent and focused devlogs this time. Hi everyone, and welcome to yet another devlog about a village building game I'm making alone with my own engine. This year didn't have a graceful start for me, if I put it mildly. A lot of things happened, some of them truly terrible, and let's just say neither of them helped me with working on the project. In particular, I teach the course about ray tracing at the local university, basically teaching students how to generate images like this, this or this. This course was taking literally all of my energy for several months. Later, I even decided to implement this ray tracer on the GPU as an exercise, and I'm planning to open source it when it's finished. I also participated in yet another game jam, specifically the 7 Days Roguelike jam, and honestly I think it's one of the best little games I've ever made. I'll put a link to it in the video description, and seriously, I'll be really happy if you try it out. Around the same time I had yet another game idea stuck in my head, the one about constructing funny vehicles and exploring alien planets with your friends in multiplayer. I had a lot of fun with the prototype, and for some time I was seriously considering switching to this idea as my main project, but after a lot of thought I decided it's time to return to the village builder. I once saw somebody on Mastodon giving advice about which games to make when you are choosing from a bunch of different game ideas. The point was that games typically take several years to make, give or take, and you don't have that many years in your life to spend making games. On average you'll make just a few games in your whole life, and it makes a lot of sense to pick those you'll be most happy working on. And since I'm already not 15 years old, I looked closely into my own feelings and discovered that the village builder is actually what I'm most passionate about. The truth is, I haven't worked on it since February, but I still had a lot of progress since the last devlog, so let me tell you about it. We ended the last devlog with a somewhat silly sandbox where you can construct funny buildings on a triangular grid, spawn villagers with a temporary human model, and watch the physics engine taking care of them. My current milestone is to have a playable demo with a tiny but functional village, which means the villagers need to be able to walk around and do stuff, which in turn means I need some pathfinding. Luckily, I have a very generic implementation of the well-known A-star pathfinding algorithm in my engine, and I just need to tell it about my pathfinding setup, what are the path nodes, and what are the edges between these nodes. Now, in a typical game based on a square grid, this is fairly straightforward. The nodes are simply the squares, and two nodes are considered neighbors if the corresponding squares share an edge. Some games also allow diagonal movement, which is also pretty straightforward. However, in my case it would mean that pathfinding nodes are the grid triangles, or specifically their centers, and this is really weird for a variety of reasons. For example, there can't be a straight line made of triangle centers, so an agent that needs to move in one direction would have to follow this somewhat wiggly path. This can probably be fixed by some path smoothing or simplification algorithm, but that feels like hiding the problem rather than solving it. Another problem is that these triangle centers don't form a uniform grid, but instead form the vertices of a hexagonal grid. What it means is that if I have a bunch of people gathering in one place, they will be spread in a weird hexagonal pattern, kind of like a graphene lattice. Anyway, triangles as pathfinding nodes don't seem to be a good idea. The obvious alternative is to use the grid vertices as pathfinding nodes, which is actually much worse. In this case, an agent wouldn't be able to find a path through a door, because there's no unobstructed grid vertex connecting two sides of the door. This in turn can be solved by allowing some sort of diagonal movement, and for some time I thought this is exactly what I'm going to do. However, there is another, more serious problem with this approach. An agent wouldn't be able to move through a one-edge wide hallway, because again there are no grid vertices inside it that the agent can use as a path. So grid triangles don't work for me, and grid vertices are even worse. Thankfully there's a third option, the grid edges. This took me a while to figure out, but using edge centers as pathfinding nodes is almost perfect for my case. They themselves form a more complicated grid, but it's still more uniform than the triangle centers. Straight lines are easily possible, and there is no problem in moving through a narrow hallway or passing through a door. It did seem weird at first, but the more I used it, the more I liked this solution. And so that's what I worked on next. I made sure that villages can't move through walls, fences and steep cliffs, and that was it. I didn't implement moving through doors yet though, because that requires some form of interaction with the door, and I'll work on that later. My next plan was to prototype some extremely basic AI for the villagers. One thing that they definitely need is food, and the simplest way to find food is just to forage it in the woods. So I sprinkled these lovely mushrooms around the trees. Raw mushrooms are bad though, so the villagers will probably want to roast them over a fire. So I need to create a fire. I had to add the basic point light support in my engine, as well as emissive materials. I wasn't sure how exactly lights should look like with this cartoonish art style. Making them work just as typical point lights that get continuously dimmer with distance looked out of place and just horrible. Making the light level binary worked better, but it lacked the feeling of a light source. In the end, I decided to quantize each light into 4 sectors with different levels of light intensity, which looks alright. To support several lights, instead of adding up the contribution of each light source, which would look like a total mess, I ended up taking the maximum over all light sources instead. All this may sound a bit involved, but in reality this is just a few lines of code in the shader. Notice that the campfire model itself is a bit weird. The white part is clearly inside the orange one, but we can still see it from any direction. That's because the whole model is inverted, meaning its normals are pointing inside instead of outside, and instead of rendering the front of the mesh, the engine draws the back of it. But it's not really a fire without any smoke, right? So I implemented a basic particle system that spawns smoke particles that get blown away by the wind, and I think it adds quite a lot to the atmosphere. I also stress tested the engine by spawning thousands of particles per second, and it worked just fine. Now, you could point out that I didn't really need all that, and that I implemented campfires just as an excuse to work on lights and particles. And you'd be absolutely correct. However, I had a lot of fun doing that, and it's extremely important to work on fun stuff from time to time, in order not to burn out. Oh, and I forgot to mention the day-night cycle that I've added, in part to test the campfires, but more importantly to help me settle down on light intensities, color schemes and tone mapping for the game. At this point I really had to start working on some AI. To make things more manageable in the future, it's always a good idea to stick to some well-established pattern or framework. One such pattern is called behavior trees, and I've even got a pretty good implementation of them in my engine already, but I don't really like this approach anymore. Another approach that seemed promising is called goal-oriented action planning, which can be described in fancy language as finding the shortest path towards the goal in the graph of all possible states of the world. In practice, it boils down to the same A-star pathfinding algorithm, it's just that the paths are now somewhat abstract. This approach is known for making the AI do interesting and unexpected things, which I think really suits my game. Using this goal-oriented approach, I implemented a very simple AA for the villagers. During the day, they just wander around randomly, while at night they try to find a campfire to sleep near it, or if the campfire is too far away, they just sleep on the ground. It's all extremely basic logic, so for now it's too early to say if this approach suits the game. That's more or less all I've got for you today. Don't forget to hit that like button and subscribe if you're interested in the project. We still have a long way to go, but I'm feeling excited about it. I see you in the next video, which hopefully will take less than 4 months. Bye bye!